Yes, students. Today we are going to find out find out the problem mod sin z and mod cos z. These are the two values we are going to find out. Okay. So for this, we'll take sin z is equal to sin x plus I by, where z is nothing but equal to x plus I by, and this is sin a plus b form, sin a cos b plus cos a sin b. So I'll find out the value of cos Iy and sin Iy. So that we will be having like this, cos Iy is equal to, we have the formula e power Iz plus e power minus Iz by 2. That's the cos. And sin is nothing but e power Iz minus e power minus Iz by 2i. That is sin. So now we are going to find out with the help of that cos Iz. Okay, so e power I into z, in the place of z there is nothing but Iy. So in the place of z is also Iy, so minus Iy by 2. So this is I into I square, so minus 1 and minus y, and this is nothing but e power y minus I into I square minus 1, so minus and minus will get cancelled, will get plus. So this is nothing but a hyperbolic function, that is nothing but cos hy. Similarly, sin Iz means sin x, you will have that e power Iz minus of minus e power minus Iz by 2i. So similarly you will be getting as like this. Now I am just taking e power Iy to this side, so taking minus common, so minus into e power I minus e power I, and minus and minus plus, again you will get same. This minus I am writing as I square, that is nothing but minus 1. So I and 1i will get cancelled, we will be getting as I into e power y minus of e power y by 2. So I sin hy you got. Now this value and this value will substitute in this. So you will be getting a sin hy cos hy plus I cos h sin hy. So sin hy cos hy plus I into cos h sin hy, you have to remember forever this. Now this is a real part and this is the imaginary part. Now after getting these two, then we'll take the imaginary as a real part. We'll try to take the real part such that you'll be getting this. So real part. So first we'll try to find out the mod. The real part is this. So mod, I wanted to have mod sin z. So I may write as sin z square. I'll write as sin z square, so that this is nothing but x plus Iy. If you take mod x plus Iy, that is nothing but x square plus y square, because square already we have taken. So this is sin square x cos hy, cos square hy plus this is also cos square x sin h square y, sin h square y. Now this is what we have. Okay, now you can change this one. I am writing as sin square hy, so I am writing as sin square x as 1 minus cos square x. You can change either anything. Now this is cos h square y plus now I'll change this one. This one if I change, now this is cos square x will be like this, and this is cos h square y minus 1, because since cos h square y minus sin h square y is equal to 1. This is the hyperbolic function identity. So according to this, cos h square minus 1 is nothing but equal to sin h square y. So from here, from that we have taken like this. This is 1 minus cos h square x cos h square y plus cos square x cos h square y minus cos square x. Okay, so these two will get cancelled. You will be getting as 1 minus cos square x. You got as 1 minus cos square x. Oh, one second. You got as, this is cos h square y, multiplying 1 inside. So you will be getting as cos h square y minus cos square x. This is mod sin z whole square. The mod sin z whole square is this. Okay, cos square cos h square y minus cos square x. Okay, now this also you can change. You can change in the further this thing. Now this cos square x you can change as 1 plus sin h square y minus 1 minus sin square x. Now this is 1 plus sin h square y minus 1 plus sine h square, sine h square x. This 2 gets cancelled. You will be getting as sine h square y plus sine square x. You got as mod sine z whole square. Mod sine z whole square is sine square x, sine square hy plus sine square x. Like this you can do the other problem also. Okay, that is, you can write it as, if you take mod, you wanted to have mod, so mod sine z is equal to under root of sine h square y plus sine square x. Now this is how we will get the mod sine z. In a similar manner, we can find out the cos z also by taking cos x plus iy. So that you can do it as a work. Okay, we can practice that. Okay, like this we can do sine z and the cos z value also. Okay, now we'll try to find out next problem. Find the roots of sine z is equal to 0 as well as cos z equal to 0. This is another problem. Or you can find out, you can write this as in the form of find the zeros of sine z and the cos z. Find the zeros of sine z and the cos z. Now this problem we are going to find out now. We are going to do now. Okay. So the first one, solution. How to do this problem? So 0 means it should satisfy the given equation. Then we can say that root you have to find out so that it will satisfy this. Now we'll try to find out this one, the first one. Okay, the first one will take, I'll take sine z. Sine z is equal to, just now we have written, no, the sine z is nothing but sine x cos hy plus I cos x sine hy. By previous problem we can able to write sine x cos hy plus I into cos x sine hy. This is from the previous problem we have done. Okay, now what he has given, sine z is equal to 0. He has given that sine z is equal to 0. So therefore sine x cos hy plus I cos x sine hy equal to 0. So that implies sine x cos hy equal to 0 and cos x sine hy equal to 0, equating imaginary and real part to the 0. This is real part is 0 and imaginary part is also 0. From this we are going to find out the value of x and the y. X value and the y value we are going to substitute so that we will get the z. So first we can take this or we can take this. So what we will do is, I will take this one. So now consider sin x cos hy equal to 0. I am considering this sin x and cos xy is equal to 0. So what is that now? Since cos hy equal to 0, cos hy is equal to 0 means you will be getting as e power y plus e power minus y by 2, which is nothing but not equal to 0. This may be greater than 0. This may be greater than 0. Therefore sin x will be 0. So sin x is nothing but equal to 0. When sin will be 0, when x is nothing but equal to n pi, that will be 0. So therefore x is equal to n pi, where n belongs to the integers. So what you got here is, you got the value of x as this, because we have not taken this is not equal to 0, and therefore this is not equal to, this is equal to 0. Now we need to find out the value of the y. So I will take this term. So consider cos x sin hy equal to 0. Now cos x is nothing but n pi sin hy equal to 0. So sin n pi means what? What you will get n pi? N pi means, I'll rub here this one. Okay, n pi. So n pi means what? N pi means I make it as minus 1 whole power n sine hy equal to 0. So you will be getting as if it is n equal to odd, you will get minus 1, n equal to even, you will get 1. So I am writing as minus a whole power n, depends upon n, the value will be. Okay. So therefore if I write if n is equal to 2m, then I may get as sin hy equal to 0. So sin hy equal to 0, that indicates what? When sin will be 0, sin 0 is 0. So therefore I may get y equal to 0. So what you got? Y equal to 0 and x equal to n pi. So therefore what I got is, therefore x is equal to n pi and y is equal to 0. But what is n? N is nothing but 2m. So I may write it x is equal to 2m pi and y equal to 0. So what is that value now? Z is equal to, so z is equal to x plus iy. So that implies 2m pi plus I into 0. Okay, 2m pi plus I into 0. So therefore what we will get here is 2m pi, where m belongs to z. Now this is the value of z by taking the sin z equal to 0. Okay, this is the value of z. Okay, next we will try to prove cos z. Cos z. What is the cos z now? The second one. Cos z is nothing but what? Again you have to do cos z means cos, actually you have to do cos x plus iy, and you can write cos a cos b minus sin a sin b, like that. Again you have to find out. So I am writing directly the value which we get after finding those all values. Cos x cos hy minus I sin x sin hy, you will be getting as this one. So since cos z is nothing but equal to 0, that implies cos x cos hy minus I sin x sin hy equal to 0. So that implies equating real and imaginary part. So this is cos x cos hy equal to 0 and sin x sin hy equal to 0. Both the values are nothing but equal to 0. So first what I will take is, I will take this one first. Now consider sin x sin hy equal to 0. So sin x sin hy is may not be equal to 0. So sin x is nothing but equal to 0. So I may take this as sin x, as when the sin x will be 0, sin x will be 0, I may take it as some sin 2n plus 1 pi by 2 into x sin hy equal to 0. Okay, so before that we'll try to take like this, so that it will be easy for us. Okay, so therefore this implies I'll consider this, otherwise I'll consider this, so that we'll get answer very easily. Consider cos x cos hy equal to 0. That implies this may not be equal to 0. So this may not be equal to 0. So I may say that cos x equal to 0. This may be not equal to 0. So therefore x is equal to 2n plus 1 pi by 2, where n belongs to z. So when x is nothing but the general solution of cos x is nothing but this, 2n plus 1 pi by 2 is nothing but equal to 0. So therefore x is equal to this. Now we'll take this now. So now sin x sin hy equal to 0, sin 2n plus 1 pi by 2 x sin hy equal to 0. We got x from here. Okay, now this is what? This is, I can say, minus 1 whole power n sin hy equal to 0. Because this is nothing but depends upon the n value of n, it will be minus 1 and the plus 1. So minus 1 whole power n sin hy equal to 0. So therefore what you are going to have? So I may take, if n equal to 2m, you may get as sin hy equal to 0. So therefore y is nothing but equal to 0. Sin will be 0 if n is nothing but equal to 2m. So what I got here, y equal to 0 I got, and x is equal to nothing but 2m. Okay. Okay, like this if you do again it's a problem. So one thing we'll do, like this we'll write minus 1 whole power n is equal to 0, sin hy equal to 0, then y equal to 0. So y equal to 0 you got, and x equal to this one you got already, you got x is equal to 2n plus 1 pi by 2, so therefore y is nothing but equal to 0. So the solution of cos z equal to 0 is equal to z is equal to x plus iy. So therefore z is equal to, what is x? X is nothing but 2n plus 1 pi by 2 plus I into 0. So z is equal to 2n plus 1 pi by 2. 2n plus 1 pi by 2 for all n belongs to integers. See, here also you can say if you take n equal to 2m also nothing will happen, because it may goes to 0, because these two terms which is 0. I am taking this one is nothing but not equal to 0, and this may be equal to 0. Therefore y is nothing but equal to 0. So this is may not be equal to 0. Let us suppose for example these two like this. So that y got 0. So therefore y, if you substitute 0 you will be getting like this, and x you already you know 2n plus 1 pi by 2. So that is equal to 2n plus pi by 2 is the solution for the cos z is equal to 0. Like that you can find out sin z equal to 0 and as well as cos z is equal to 0. Thank you.